Now we'll cover the dot product. And of course we start with vectors. So here's 2. First I'll draw that point, 3, 0 and 4, 4. Let me try to draw some arrows leading to those two. So here's 2 vectors. Whoa. Okay, and we want to find the angle between these. Okay, and I'll use the convention calling the angle theta, that Greek letter theta. Well, finding that theta is pretty straightforward here, since that 4, 4, if I drew it a little bit better, is a 45-degree angle. Right? It's supposed to go through 1, 1. So that's pretty easy to solve this one, just looking at it. But we could appeal to a triangle to calculate that angle. Right? Do you remember how that goes? We could appeal to SOHCAHTOA, where the angle in focus is here, so that means this is the opposite side, this is the adjacent side, and this is the hypotenuse. Okay? So if I found this length, for example, I could find the angle by using this. The cosine is just the adjacent, length of the adjacent over the hypotenuse, like this. And I could rearrange it to find the angle like this by using the inverse trig function here, like that. Okay, keep that in mind. We're going to look at something new entirely here. It's called the dot product. Okay, so we start with 2 vectors, and I'm going to do something slightly different. I'm just going to denote the vector with a little arrow hat on it. Some authors do that, not everyone does, and I'll just say that this vector is in 2 dimensions, just meaning that it has 2 entries in this ordered pair, and I'll call it A1 and A2, and I'll have my other vector B, B, B1, B2, like this. So just another ordered pair. Okay, so I introduced this new operation. Looks like multiplication, but it isn't. Okay, it's not multiplication because these aren't numbers, so you can't multiply vectors together. So we create this thing called a dot product. What this is this peculiar looking thing. It's the length of the A vector times the length of the B vector times the cosine of the angle between them. So this is the angle between them. A and B. Okay. So that looks pretty complicated, but it is one way we can come up with the angle between any 2 vectors. It doesn't matter their position. But now how to calculate them, not at all apparent on the right-hand side. It turns out this is an extremely easy calculation to perform, which makes the dot product a very useful thing to do. All we do is we take the product of the first 2 entries, so A1 times B1, and then I add it together with A2 times B2, these 2 guys. Okay, and that's it. So when I take the dot product like this, it will give me the angle between them in a certain way. Let's actually perform that calculation, and we'll use the vectors from last time. So let's take an example. Let's take the vector 3, 0, and we'll also take the vector 4, 4. Okay. And I'll calculate the length. I notice I need the length over there, so I'll calculate the length of A. I don't have to do a calculation at all. You can just look at this and say, oh, the length is 3. The length of B is a little more complicated. Here, I have to take the square root of 4 squared plus 4 squared. Okay, and that's the square root of 32. I'll just leave it as the square root of 32. Okay, so now let's calculate the dot product of A and B. So the dot product of A and B is just 3 times 4 plus 0 times 4. That just gives me 12. Okay, so that's it in terms of the dot product. The dot product of A and B is 12. Done. End of story. But what we can use that dot product for is to find the angle between A and B. Okay? So I can take, I'm looking for the angle between them. So I would divide both sides by the lengths of A and B and take the inverse cosine. So it would be A dot B over A, the length of A, times the length of B, like this. Okay, so to find the angle between them, I just take the dot product, which gives me 12, divided by the length of A, which is 3, times the length of B, which is the square root of 32. You can actually simplify that a bit, and at this stage you could use your calculator if you wanted to. But this is going to be 1 over the square root of 2. Okay, see if you can do that. I just did that quickly in my head, a little too quickly, because this should be 2 over the square root of 2. And if you remember your unit circle, which is a nice thing to review, if you haven't seen it in a while, you can also just put this into a calculator. This is indeed going to give you a 45-degree angle, but now I'm going to write it in terms of radians. This is pi over 4. Like this. Okay, which is exactly what we expected to see. Alright, I'm going to pause this video here, and I'm going to rejoin us with another interpretation of the dot product.